in this case, the automated analysis like VirusTotal or FileScan will fail to discover the link we were talking about for our file. I literally didn't find any threads. As you can see, PDF does not contain any clickable URL, which is wrong. Today we are going to be talking about malicious PDFs, and we have received, as you can see, an email. That was a couple of weeks, maybe 3 weeks ago. I'm just getting to it now. With apparently PDF document attached and asking us for some, I don't know, investment or something like that. First things first, as we can see, email is some randomly generated email at gmail.com. Also, the name of the PDF is pretty long-winded, which is not something what human being would normally save. They would normally give some meaningful names. I've also, you can see this purple bar in here. I've basically blacked out all the recipients of the email, and there was like a huge chain of them. So let's get on to it. We can see the image here, some person on the car, whatever. This is something about the building or investment in the building or something like that. We're gonna find out soon. So we've got a PDF document we didn't expect from some Penny Kozatek. No picture, obviously, no subject. That raises suspicion straight away. But the most important part is, how do we actually investigate the PDF document? So I'm going to show it to you now. Let's move over to Linux machine. And as I said before, I've got investigation machine prepared, connection to the internet. Normally, if you investigate malware or viruses in the form of executable files or any other files, you would start your investigation with no internet connection. However, I've decided to turn the internet connection on because there is a link in that document which apparently document should connect to. Now, obviously, I've done the investigations ahead just to check what it is and how it works. So I'm just gonna be speeding up in here and then showing you what steps you can take to actually find out what that PDF is. So first of all, let's see, we've got PDF. This is the name of the PDF there, which, as you see, is long. So I'm gonna just move it to different name, and I'm gonna call it malpdf.pdf. Sorry, there you go. Now, how do I know it's the same file though? If I do md5 sound, that's gonna give me a hash, or actually I could do SHA-256 some of that malicious PDF. That gives me that long string, which is a hash, which is one-way mathematical function, and this will actually tell me whether that file, which we just here and which I copied to different file, whether it's the same file or whether something changed. Basically, this helps us to establish the integrity of the file. So if I do now the other one, which was mal PDF, there you go. And as you can see, it's actually the same file. What you can check just slightly the beginning there, it starts the same, and then if you take quite a few numbers at the back, if they are the same, it usually means it's the same file. We could go letter by letter and a number and see whether it's correct, but it should be correct at this time. It's really hard to forge that, especially when it is SHA-256 hashing algorithm. Now, so we know those two files are okay. Let's have a look at the file, actually. So now, as you've seen in the beginning of the video, that PDF in the email shows with some kind of photo. However, in our folder, that photo is not visible. So what's going on there? Maybe just our Linux machine, when you go to the folders, it doesn't actually read that properly. That is a possibility. However, to stay on the safe side, what I am going to do, I am actually going to run Wireshark just in case. so just to see if anything happens on that PDF. I'm gonna review that later. Now let's try to open that PDF. Let's try with the original first. It says that the document is damaged for whatever reason. Okay, let's see. That one should, yeah, it gives us the same. That's expected. All right, let's open it in the text editor and see what we're gonna get there. Let's do small PDF just in case. Okay, open anyway. Open as text. All right, so this is what you can see normal in PDFs. You've got your PDF header giving you the version of PDF. This one is 1.7, and it gives you objects. And at the end of the PDF, we should have a X reference table, which references the objects we've got. Now, the problem, normally you've got end of object, but you see here only one end of object. You don't have an end of stream. You don't, oh, actually there's another one here. Okay, so that works. This one's gonna be correct. End of object here. I thought the first time around I investigated, I couldn't see those. Alright, so end of objects are there. Apparently, we can see there's a stream in here, and apparently it's got some kind of an image. How do we get that out? Because this is all encoded in streaming DCT decode, so we can't read it with our eyes, but I will show you how to get that out. Now, what's interesting is, it's got some other streams. The problem is you can't read them like that, not in the text editor. So you need to somehow sort them out. Now there is probably an issue with some of the streams. That's why the document doesn't display properly, or the document's got some quirk which will only work on certain software which displays the document. For example, Adobe, or maybe a specific type of browser like Firefox or Chrome or Edge browser. So let's try to open it in the browser and see whether that works. Because that might be the case. Hang on. So let's go back to our files. Let's see if our browser is gonna read that. No, so we're not getting anything for that. Okay. So what can I do next? Let's see if we captured anything there. Obviously, we've opened the browser, so we can see it there. There is some connections to this port. Let's see what's that is. No. It doesn't seem it's our thing. Okay, so let's keep it running for now. Now, the first thing I usually do with PDFs is PDF ID. You can download it from GitHub or whatever. That's it's alright. I will paste the link in the description of the video, so that's not a problem. And just put that PDF in there and see what we've got. So as we've seen in the text editor, we've got PDF version 1.7, and we've got number of 5 objects and 5 end objects elements in there. That's fine. We've got 4 streams, and we've got object stream as well. What it looks like it. We don't seem to have any URLs or JavaScript embedded, which normally malicious PDFs would have or can be picked up on, or any forms either. So this is a bit weird what the attacker tried to achieve. Now let's dig into that and see what those object streams are, because the object stream in the PDF can be used to obfuscate the things like URI, like URLs or any other scripts. They basically can be encoded in object stream, and that's why we may not be able to see it. So to make sure, let's try something else. So we already know we've got some object streams. Now what we could do is PDF parser, and we know we've got object streams there. We want to read them. So in order to be able to read them, capital O. Actually, let's do help, and you can see capital O in help is object stream, parse streams of objects as well. Otherwise, we're not going to see that. So if I just do PDF parser and .pdf. We've got objects in here, but we don't see any streams. Like object 7 had a stream, remember, in the text editor. And this one just gives us information about the object, and it says it's an image. So that's good to know. That's fine. We could also set it up after the decode type. This decode type, by the way, it's going to be JPEG. So that image we've seen in our starting screen here, that image is probably that object stream we are looking here now. So this is probably that image. We'll try to get it out to confirm. And other than that, we've got some comments, some referencing as well. So the way the PDF is built, basically, you've got object, your object number, and that object can also reference some other object. And I'm trying to find whether this one does, actually. I can't remember. Nope, nope, nope. No, so it looks like everything is like in almost one object, but we can't read the object streams yet. So we know the capital O in that instance was something what reads object. So let's try to see that and what this does. Now we can see that object 12 is containing object stream 14 and is referencing object 5, object 4, and object 7, which is the image. We also see they are at the 0 revision, so there was no other version of it saved. So, there we go. We've got something right. All right, this was quick. Object 9 actually is containing object stream 14, which is again similar to that one. So it looks like every object here is containing object streams 14. So all the other objects are made of that object stream. And what we can see already, because we parsed some object streams, we can already see there is an URL, which seems to be URL to Google, which actually isn't. And as we can see here, the query is for another URL, and site actually with IP address, not a domain name, which is a bit unusual, actually. Nowadays, most of the attackers use some domain names, and they try to circumvent the filters that way. This is straight to IP address, so it actually circumvents the DNS monitoring. So if you've got any blocking on DNS traffic setup on domains, that will not trigger because it goes directly to IP address, skipping all those filters you may have on your firewall or on your EDR and your network detection system as well. And obviously some other arguments, which is fine. Okay, we can just copy that link and check what it does at this time. But we said we want to check whether that image actually is linked to anything of that. That's annotation. Okay, link. Brilliant. Oh, there we go. You've got something here. So you've got more object. In object 1, you've got object stream 14, basically. It contains everything else. This is a flat ID decode. Something is wrong with it because I've tried to decode it and I couldn't get the actual text. It didn't parse that text. Even using the filter option, I'm going to show you that in a minute. There you go, flat ID decode as well. So this is our image on object 7. Let's deal with the image first. So let's go back, let's clean the screen, and let's bring that up. And we need to read object stream, otherwise we aren't going to be able to see it. And we said it's object 7. And we should be able to just dump it to image, and I know it's JPEG because of the decoding of the GTC decoding used. So let's see what's gonna happen. Okay, and how we got image. All right. There you go. So this is so basically that's the image we've had in our PDF, as you can see on our beginning there. It's exactly the same. Now, it makes us to believe that we can make €8 a day very easily, guaranteed results, whatever. It tries to convince us to basically click into it, and we got some guy leaned against Porsche, whatever, just to make us think we can earn that, that's fine, and then get us to click the link, basically. Now, what's interesting is which I'm going to show you on our Windows machine, that actually entire photo is actually a link. That link we've seen now for Google is actually attached to the entire photo. It's not only to the button there. And maybe let's switch to our Windows machine and see how that works, how that looks like there. So we are at our Windows machine. We see the, so the SHA-256 is the same SHA, it's the same, it's the same hash we've had of the image before. I think we can actually compare the hashes. Can we do that? One sec. Let me go to the Linux machine and let's switch that one off. Let's do again 256. Let's compare the original one. Okay. So what you should be able to see now, should be able to see that this SHA in here, it's the same as in our Windows one. So where's our Windows one? Oops, sorry. So that SHA is, this SHA here is the same as our Windows SHA-256 in here. It's got the same numbers at the end of it. If you can see 4303C80B12. So it's the same file, but that's what I'm trying to say. It's the same file. Let's go to Windows machine only. Now, if we open it, oh, there you go. It opened it. Wow, that's interesting. Now, okay, what's that? It opened it in Edge. Okay. Anything else there? Let's close that and see again. No. What happens if I click it? Okay, well, this is brilliant. Google actually gave us notice that they tried to redirect us to that number, to that address. And this is the page apparently they are looking for. So let's click on that and see what's going to happen. We don't seem to have any other. We don't seem to have any other processes spinning out. Okay, it cannot reach that site. So it may be, as I said, I got that email probably 2 or 3 weeks ago. Maybe someone is already blocking that IP. Maybe it's already taken out. And now what we could do though, we could check the IP actually and see how does it look like on VirusTotal. VirusTotal. There you go. Seriously? All right, I'm gonna check that IP actually on the Linux machine. So let's go back to the Linux machine. And let's check that IP. Let's get the URL out first. So we said there was a URL in object. We actually can't remember which object that was, can we? So there is another nifty trick we can search for the object. There we go. And that's where the IP is. Let's go copy that. What I like to do actually is go to that tab. If I could spell, CyberChef, trusted tool. There we go, paste, URL, decode, and now I've got the IP address. I've already checked it before, as you can see. All right. So that IP address itself is only recognized by 4 vendors for phishing and malicious email, basically. No comments yet from community relations. So we can see that IP also has been associated with other websites. and other documents with the other names. It is possible. Well, that one actually is critical here. 63 out of 70. So someone was basically trying to upload the DLL and then exploit the system with the PDF document called, or any other document like, sorry, this isn't PDF, this is a DLL library. First seen registered in Russia. Interesting. Yeah, so basically that IP address apparently is connected to Russia. And to Russian domains and Russian operations. So, interesting. Last analysis was 1 month ago. Maybe they started blocking it since then, and that's why we can't access the site. It's possible. So now we've got that. That's fine. We know we've got the URL. We've got the image. We know the image is actually the URL is actually attached to the image, and the whole image is click. So if you click anywhere in the image, even by accident, you're supposed to go to that site. Now, because we can't get into that IP anymore, our communication didn't go through. But what is important again, this is a clever use of Google search query, where you're basically using a normal Google URL. And you just query as a search. Apparently you searching the query, but that's gonna redirect you to that URL using Google. So you will think, normal user will think, yeah, I went through Google, that's safe. Now, fortunately, Google now tell us that we, as you've seen in the Edge browser, that we were going to be redirected there, and it didn't move there until we click into it. So if you've seen things like that and you weren't expected to be redirected anywhere, just quit the window and don't follow. Now, this is just one way the PDFs can be exploited. Another way that could happen, that PDF actually could have some JavaScript or some other scripts or some other forms where you would have JavaScript triggering, and then it would trigger Node.js payload or whatever the attackers wanted, or bash script or shellcode as well. We've seen those before now, so be careful when you're opening the PDFs. What I usually do, if I don't expect the document, and this one is pretty much more obvious, this one is from the easier one to spot. As we said on the beginning, you can see weird name, no subject, and some weird emails. Just don't touch it. Mark it as, report it as phishing, and get rid of it. If you don't know what to do with PDF document, if you didn't expect it and it looks almost legit, but you're not sure, you don't want to open it, it's good to have a virtual environment to do that. What you could do with that file, you could submit it to VirusTotal or filescan.io and check whether that file is malicious or not. Now, in this case, I'm going to warn you, the automated analysis like VirusTotal or FileScan will fail to discover the link we were talking about. So let's see what's going to happen. Let's go to VirusTotal. Let's submit the file, the original one. At the minute, there is nothing there. Yeah. Now, someone was actually analyzing it 8 days ago, so brilliant. It wasn't me, by the way, but it's great. Now let's go to FileScan. I've already submitted it to FileScan today, so it should be there. There you go. So we've got analysis report for our file. I literally didn't find any threads. As you can see, PDF does not contain any clickable URL, which is wrong. We know we've seen the URL, we've seen the redirection of that URL, and we know that it was redirecting us to Russian-controlled IP address. Now, what it also says, it says that it contains high entropy data, so a lot of random stuff, and really dense as well, and it's associated with software packing. So basically what it does, the FileScan.io scan the file with their automated analysis, and because all that link, as you've seen, is hidden in the object streams, it couldn't actually see the link. Now, if we've hidden JavaScript in object streams, those automated analysis methods would not pick it up because they cannot decode it. Now, so don't rely on them. full on. If you're not sure, download the tools I was using. The links are in the description, and play with them and see how you can analyze and check different PDFs. And always do this in the virtual machine environment. Click like and subscribe if you like that content. This is my second video. I'm looking forward to making more videos like that. As you've noticed, I'm trying to show you the phishing emails, which I get, which I can catch myself. However, everyone else will probably catch something different, similar, and other different emails. So if you want to see more, I will give you an email address at the end of the video. You can send me things like that. And when I get time and get around to it, I will be investigating them and posting video of that. Thanks for watching. And once again, like and subscribe. Bye.